According to the National Fire Protection Association 20 standard for the installation of stationary pumps for fire protection, the fire pump shall be supplied by a power source separate from that used for the operation of the protected premises. This requirement means that the fire pump circuit should not be connected to the same electrical distribution system that supplies the rest of the building. The primary reason for the separation is to ensure that the fire pump has a reliable power source available in the event of a power failure or other emergency situation affecting the normal building power. By having a dedicated and independent power supply, the fire pump can continue to operate and provide essential fire suppression capabilities even when the main power to the building is disrupted. This is critical for maintaining fire protection and minimizing potential damage during a fire. In practical terms, this means the fire pump circuit must originate directly from the main service entrance of the building or from another approved independent power source that meets the requirements outlined in NFPA 20. It should not be connected to any subpanels, distribution boards, or other electrical equipment that also supply power to other building loads. The intent is to isolate the fire pump circuit as much as possible from any potential electrical faults or disturbances that could affect the overall building electrical system. In this specific scenario, the fire pump circuit for the new pump and controller should be fed directly from the main 1000 amp service, rather than the 600 amp distribution section. This ensures that the fire pump has its own separate and reliable power source fully compliant with NFPA 20 requirements. Failing to adhere to this separation requirement could compromise the reliability of the fire pump during an emergency, potentially leading to inadequate fire protection. It is important to consult with qualified electrical engineers and fire protection professionals to ensure that all fire pump installations meet the applicable codes and standards, including NFPA 20, and that the power supply arrangements are properly designed and implemented to provide the required level of reliability. Firstly, understand the scope of NFPA 20. This standard covers the installation of stationary pumps used for fire protection, including the power supply requirements. Secondly, recognize the critical importance of a reliable power source for fire pumps. These pumps are essential for providing water to fire suppression systems during emergencies. Thirdly, appreciate the intent behind the separation requirement in NFPA 20. This requirement is designed to ensure that the fire pump has a dedicated and independent power source, unaffected by potential failures in the building's normal electrical system. Fourthly, identify the main service as the preferred power source for the fire pump. This is typically the most reliable and direct source of power available. Fifthly, avoid connecting the fire pump circuit to any subpanels or distribution boards that also supply power to other building loads. This helps to isolate the fire pump circuit and minimize the risk of electrical faults affecting its operation. Sixthly, consult with qualified electrical engineers and fire protection professionals to ensure that the fire pump installation meets all applicable codes and standards. This includes proper sizing of conductors, overcurrent protection devices, and other electrical components. Seventhly, consider the use of an alternative power source such as an emergency generator, if the main service is not sufficiently reliable or if required by local codes. Eighthly, ensure that the fire pump controller is properly designed and installed to automatically start and operate the pump upon detection of a fire condition. Ninthly, regularly inspect and test the fire pump system to verify its proper operation and reliability. This includes testing the power supply, pump performance, and control system. Tenthly, maintain accurate records of all inspections, tests, and maintenance activities performed on the fire pump system. This documentation can be valuable for demonstrating compliance with applicable codes and standards and for identifying potential problems early on. The National Electrical Code, or NEC, also plays a crucial role in ensuring the safe and reliable installation of fire pump electrical systems. The NEC provides detailed requirements for the wiring, overcurrent protection, and grounding of fire pump circuits. These requirements are intended to minimize the risk of electrical hazards and ensure that the fire pump can operate reliably during a fire. Article 695 of the NEC specifically addresses the installation of fire pumps. This article covers a wide range of topics, including the power source, wiring methods, overcurrent protection and control circuits for fire pumps. It is essential to carefully review and comply with Article 695 when designing and installing a fire pump electrical system. One of the key requirements in Article 695 is that the fire pump power source must be reliable and capable of providing the necessary power to operate the pump under fire conditions. This typically means that the power source must be separate from the normal building power and must be designed to withstand the rigors of a fire. Article 695.3 A1 states the supply shall be either a service connection or derived from an on-site power production facility. Article 695.3 A2 states that the supply shall be located and arranged so as to minimize the possibility of damage by fire from within the premises and from exposing fires. Article 695.3 B1 states the supply equipment shall be located and arranged so as to minimize the possibility of damage by fire from within the premises and from exposing fires. Article 695.3 B2 says that where reliable power cannot be obtained from a source described in 695.3 A, the fire pump shall be permitted to be supplied by one of the following. First, an approved combination of an on-site power production facility and energy storage system arranged such that the facility starts upon failure of the normal utility source and the energy storage system picks up the load until the on-site power production facility is up to speed. Second, a listed fire pump controller with an alternative source of power. Article 695.3 C states that sources shall not be interconnected so as to allow direct feed of power into the utility system. The NEC also specifies the types of wiring methods that are permitted for fire pump circuits. In general, the wiring must be installed in rigid metal conduit, intermediate metal conduit, or electrical metallic tubing. These wiring methods provide a high degree of protection against physical damage and fire. The NEC also requires that fire pump circuits be protected by overcurrent devices, such as fuses or circuit breakers. These devices are intended to protect the wiring and equipment from damage in the event of a short circuit or overload. The overcurrent devices must be sized appropriately for the fire pump motor and the wiring. Article 695.5 states that a fire pump disconnecting means shall be selected and installed to withstand the peak inrush current under locked rotor conditions of the fire pump motor. Article 695.5 B states that the disconnecting means shall comply with all of the following. First, it shall be identified as suitable for use as service equipment. Second, it shall be lockable in the on position. Third, its location shall be remote from other building disconnecting means. Fourth, it shall be readily accessible. Article 695.6 states that overcurrent protective device or devices shall be coordinated to provide selective tripping. Article 695.6 B1 says overcurrent protection shall comply with one of the following. First, the overcurrent protective device shall be sized so that it will carry indefinitely the sum of the locked rotor current of the fire pump motor and the full load current of the associated fire pump accessory equipment. Second, where the locked rotor current exceeds the trip setting of the instantaneous trip circuit breaker, the tripped setting shall be increased to allow the fire pump motor to start, but shall not exceed the values in Table 430.52. Additionally, the NEC provides requirements for the grounding of fire pump electrical systems. Proper grounding is essential for preventing electrical shock hazards and ensuring the reliable operation of the equipment. The grounding system must be designed and installed in accordance with Article 250 of the NEC. The controller is the brain of the fire pump system. It monitors the water pressure in the fire protection system and automatically starts the pump when the pressure drops below a certain level. The controller also provides various alarms and indicators to alert personnel to any problems with the system. The fire pump controller must be listed and approved for fire pump service. It must also be designed to meet the requirements of NFPA 20 and the NEC. Article 695.12 states that a fire pump controller shall not be used to supply other loads. Article 695.12 B1 states that all internal circuits for power, signal and control shall be stranded copper conductors. Article 695.12. The 2 states that the controller shall be marked to indicate that it is suitable for use as service equipment. Article 695.12. The 3 states that the controller shall be accessible. The fire pump motor is the heart of the system. It provides the power to drive the pump and deliver water to the fire protection system. The motor must be sized appropriately for the pump and the system demand. The fire pump motor must be listed and approved for fire pump service. It must also be designed to meet the requirements of NFPA 20 and the NEC. Article 695.4 says fire pump power wiring shall be kept entirely independent of all other wiring. Only equipment within the room or area that is essential for the operation of the fire pump system shall be permitted to be connected to the fire pump power supply. There are several different types of fire pumps available, each designed for specific applications. Some of the most common types of fire pumps include centrifugal pumps, vertical turbine pumps, and positive displacement pumps. Centrifugal pumps are the most common type of fire pump. They are relatively simple in design and are well suited for a wide range of applications. Vertical turbine pumps are typically used in situations where the water source is located below the pump. Positive displacement pumps are used for high-pressure applications, such as supplying water to standpipe systems in tall buildings. The installation of a fire pump system is a complex process that requires careful planning and execution. It is essential to work with qualified professionals who have experience in fire pump installation and who are familiar with the applicable codes and standards. The first step in the installation process is to determine the water supply requirements for the fire protection system. This includes determining the flow rate and pressure required to adequately protect the building. Once the water supply requirements have been determined, the next step is to select the appropriate fire pump. The pump must be sized to meet the water supply requirements and must be listed and approved for fire pump service. After the fire pump has been selected, the next step is to install the pump and the associated piping. The piping must be sized appropriately to carry the required flow rate and must be installed in accordance with the applicable codes and standards. The electrical system for the fire pump must also be installed in accordance with the applicable codes and standards. The electrical system must be designed to provide a reliable source of power to the pump and must include all of the necessary overcurrent protection and grounding. Once the fire pump system has been installed, it must be tested to verify that it is operating properly. The testing should be performed by qualified personnel and should be documented in accordance with the applicable codes and standards. Regular maintenance is essential for ensuring the reliable operation of a fire pump system. The maintenance should be performed by qualified personnel and should include the following tasks: inspecting the pump and motor for any signs of wear or damage, lubricating the pump and motor bearings, checking the water level in the pump, testing the pump controller, and testing the alarm system. In conclusion, the installation and maintenance of a fire pump system is a complex process that requires careful planning and execution. It is essential to work with qualified professionals who have experience in fire pump installation and who are familiar with the applicable codes and standards. By following these guidelines, you can help to ensure that your fire pump system will provide reliable fire protection for your building.